Very well organised. So the third lightning talk, or lightning as we see, Shu is a software engineer at AWS, works for the cloud formation. After his work, he enjoys applying machine learning to problems in his own life. Recently, that's meant experimenting with deep learning and computer vision to see if he can build a system that helps him learn partner dancing. Early in his career, he worked as an AI engineer at startup analyzing social networks, building systems that link people and concepts mentioned from social media to Wikidata, branding language model outputs in real-world entities. Take it away.
Hey. Mic is, well, it's working. Let's put this up. Just as you thought. Perfect. It's a 6-year-old laptop.
Gotta get rid of tires, man.
RAM's expensive.
Yeah, you picked a bad time for that.
Yeah.
Is it on there on display?
Okay. Let me just pop this out.
Yeah.
Here. Let's see. This works.
Oh, right.
Okay. I'm gonna start inverse. Well, I'm going to put this slide out first. So, this project is Rag in a Box. Gauri Khanolkar was the brain behind this. We want to do something different. When you think of RAG systems, you always think of, okay, I'm going to ask the LLM a question, there's something going on in the background that's going to grab some information from the LLM, and the LLM is going to regurgitate something for us. You're like, okay, but how do the things get into the place where the systems grab information for the LLM for? And we over-engineered the problem. So we'll be talking about that. That's Gauri Khanolkar, main brains behind this. This is our GitHub page, and we'd like it if you start the GitHub repository. All right, that's me. Can move on. Okay, RAG is a systems problem. What do you mean by that? So, sure, we can have like this toy demo of RAG where people just upload something, gets embedded, stored into a vector database, and then you use an LLM to answer a question. Looks simple and hides the tough parts about this. So, before we go into anything, let me just show off a very quick introduction of what a RAG is and how it works in case people are not familiar with it. Here. I had to put everything on video. I have a 6-year-old laptop. Okay, so I chose today's topic as earthworms because it's raining. It was raining, so earthworms, okay? So the question I asked the LLM is, if earthworms were humans, this was recorded by Gauri, by the way. If earthworms were humans, what specific accessory would they wear? Yeah. And it's like, interesting thought, and say something uncool. Now, we add some coolness to the LLM by ingesting a document into it about earthworms that we wrote. So you get a token back. This is async. This is like ingesting a document into LLM for it to be able to retrieve it later. Now you can query document. Is it complete? It's in progress? It's still not queried? It's a big document. Once you're done, once the document is through, you can ask that same question again. And it'll say, if earthworms were humans, they'd wear a red scarf. Perfection. It's picked up from How Do We Make Earthworms Cool? All right. That's what RAG systems are, in case somebody was unfamiliar with it. Okay, back to the slides.
Chris.
And Amazon we just use. Okay, toy rag demo. Toy rag demo looks like you just upload, you embed, you put in the vector difference, and it answers the question for you. Simple. Okay. Now, let's analyze this a little more. A user is putting stuff in through an API whose job is to chunk this into different parts, embed all of these chunks, and then store it into a vector database. One request is one full ingestion job. What do you think? What breaks first in this if 10 people upload large documents at once? Any takers for this? Try impromptu guessing.
Document ingestion.
Document ingestion.
I think it depends, like if you have a queue system, and you could get queue backlog, if you're running on a 6-year-old laptop, you might get no refresh.
I gotcha. We don't have a queue system. It's just synchronous ingestion.
It's running on your laptop, right?
Think of it running on a server.
Oh, okay.
Either works.
I was thinking maybe your laptop would break like when I was
Yeah. Happens. Okay. So, when you have a synchronous system, that same host, that same computer that's running everything has to deal with all of these different things like chunking, embedding, and storing, which will overload it. So your request is going to be super slow. One way I like to look at chunking, one way I like to look at synchronous API is, one way I like to look at this is synchronous ingestion is just saying, please hold on while I do machine learning for you. And we don't want that. So what's the solution? I'd say it's going asynchronous. What is asynchronous? You submit a request to the API gives you a token back. It's like, I'm doing a job. You can come back later. So that's what it is. Async is what happens when you finally admit that the request should not be doing the cardio. What's the other advantages of asynchronous? You can batch things into one job, group things together, and put it into the model, the embedding model. We have noticed that we have results that batching things together and putting them through the GPU at the same time is to higher throughput usually. You can scale workers. Once you go async, you can just put things up as jobs, and then you can increase the number of workers. If load increases, you increase the workers, everything works fine. There are caveats. Lastly, you can track state when you're async. I don't know why I put this as an advantage, but more to it later. So there's a shift from sync to async. In sync, synchronous, you just upload to one server that's handling everything all by itself, and then you store it to a vector store. In async, you upload, the API schedules your job to a queue, which is then picked up by individual workers. These are like on separate machines, and these workers can pick up jobs in batches of 64, batches of 128, whatever fits its CPU limits or GPU limits. And then it stores everything to the vector store. So, what is the problem with this? Yes.
Well, I mean, you're rate limited by your thread count, right? So assuming you're running your web process on core 0 and you're delegating your thread per core architecture, then once your cores are saturated, you don't have any more ability to fan out.
On a single device?
Sure. If you have a virtualized queue, then whatever the box processing is still limited either by physical threads or by virtual threads.
Right. Thank you. I didn't think of that, but you're talking about the queue limits?
Sure, yeah, right. So if you're processing it on the box itself and you're not like pushing the work out to a queue that's running on another host.
Oh yeah,
right?
that's kind of like the goal.
Yeah.
Okay, everybody's getting lost in the title. By rag in a box, I'm like, hey, wouldn't it be nice if I could just easily write on my device and then I don't write on the device in the demo. But this is totally scalable, like if you put it on different hosts.
Yeah, absolutely.
Mm-hmm. That's kind of cool. So the answer I was kind of looking for was Async solves this weird latency issue that we have while the customer is waiting. We have like huge request waiting time. It solved that, but now we have another problem to deal with. Moving work to the background is nice until the audience asks incredibly rude question. Cool, but what is it? Cool, but what is it doing right now? Which means the person that put the request in for ingesting the document in the queue does not know if this document has gone through or not. Is it failed? Is it in progress? Is it completed? So was the request accepted? Was it queue or processing? Did any chunk fail? Can I retry? What status do I show the user? All of the questions that Async introduces. So how do you fight this? Sorry, I'm skipping ahead. How do you fight this?
Acid property.
Yeah, you can have asset properties.
Add open telemetry tracing so you have visibility between processes.
Yes, that's one way. What I'm talking about is how can a user query if the document I submitted has reached the index or not?
You have a state machine that updates when the process state changes.
Yes, that is exactly what I've been looking for. You add some form of state, and I do this using Postgres. So user submits its document to the ingestion API. Ingestion API is like, oh, I've received this document. Let me put its status to in progress. It puts everything to the queue. It puts the document chunks to the queue, and both of the encoders work really hard. Shout out to these encoders. Once they are done with this, once they are done with encoding stuff and putting things in a queue, they can update the state in the Postgres database that, hey, instead of in progress, it's completed, and the user can poll and be like, hey, it's done. Yes.
What is Qdrint?
Oh, Qdrint is a vector store.
Okay.
Yeah. So this is ingestion part. The one below is query part where the user puts a query like, what is the accessory that a human Earthworm would wear, and it stuff. It just goes to the orchestrator. The orchestrator pulls out all relevant information from the vector store, Qdrint, puts it into the LLM, and LLM gives you the answer. The query part's completely unnecessary for this demo. So Python moves the work, and Postgres tracks the work. We have Python services that are doing stuff in the background, and Postgres is handling, okay, what happened to the document, what happened to the work this Python servers, all of these microservices are doing. So we have ingestion status table, which tracks the status of a document with an ID. It keeps track of the number of chunks that we have broken this document into, and how many are done, how many errored out, where it was last updating. Another column for each individual chunk that was broken down. We have chunk ingestion status, which links back to a main document, and the individual status of each separate chunk. Cool. What does each package in Python do? This service is written using most of the things like ingestion API, orchestration API, things that let you do interact with the service is written in fast API. For async ingestion, that is putting things in the queue and taking things out of the queue, we use something like PuPPy. I picked it because it has a cool name. Then we have the workflow state, which is where is this document, what is it doing, is it in progress, is it failed? This state is handled by Postgres, so we use the ORM SQL alchemy with PsychoPG2 for library for Postgres. Lastly, for retrieval, to keep things extremely simple, fast embed and a qdrint clan to put things into the qdrint and retrieve things from qdrint. Okay, so I'll just do a walkthrough of what you are a request. Imagine you are a request, you are a document. I would like to put you all in that headspace. As a document, how does your life look like?
Very flat.
I like that. All right. Oops. This is the wrong video. 2 videos. Hold up. Double the trouble. Okay. So this similar setup, but you're going to experience what a document feels like. So we are asking the we are first ingesting things in a large language model. You are worm.txt, so I'm going to crack a joke later. This is the thing where the worm wears the red scarf. It is being ingested. Takes a while, it's a huge document. Okay, oops. While it's ingesting, this is your life as worm.txt inside Postgres. You are assigned an ingestion status token. There. Oops. There we go. You're broken down into chunks, different parts of you. You are segmented by each segment you have as an earthworm.
Like a worm.
Oh.
Segments.
Yeah. You can view each one of your segments, were they put into the vector data store or not.
That tool is called Adminer, is that what that's called?
Uh-huh.
Okay. And that just lets you kind of browse what's inside the database, right?
Right.
Cool.
So your chunks are in progress now. This is RabbitMQ. RabbitMQ dashboard. It will tell you how many requests did it receive. You can track your requests through this dashboard. So one of your chunks is in RabbitMQ right now, slowly being your chunk is waiting to be processed by the encoder. And then finally, when all of your segments are true, as an earthworm, you can finally be useful and answer the question: if earthworms were humans, what specific associated with the were? Red scarves. Yes, we have a bunch of handshakes.
Does the order of chunking matter, or it does not matter?
For this context, no.
Okay, so it could be async and they could chunking. Okay.
Yes. Prefer.
How does the chunking work, and what would happen if it decided to chunk, like put a boundary in between your joke there?
Oh, that would be sad because I would not be able to crack that joke. But for this case, we have used the recursive text splitter, which is like you have an overlap.
Okay.
Things work out. It'll pull up multiple documents, so that works out too. I'll go for that one.
How many requests do you expect to queue up with Broward?
I didn't really think about that.
Hundreds? Thousands?
but yeah, thousands is what I'm going. I'm going for thousands. I have not load tested the system unfortunately.
Probably don't do it on that laptop.
Yeah, it's hard to load test. Go for it.
Yeah, so I saw a chunk status table somewhere. So can chunks, like the ingestion of a chunk, fail on a chunk level? And does this have like retries baked into it?
Right now we don't have retries baked into it, but it will fail a chunk. So you can manually retry.
Okay, so you can actually like submit the chunk ID or something and just try to ingest that again.
No, we don't have that. You gotta put the document back, unfortunately. We'll work on that, yeah.
Does it upload the full text to RabbitMQ, or does it upload somewhere else?
Uploading full text to RabbitMQ, it will not work because RabbitMQ has message limits. We don't do that. It'll upload somewhere else. The ideal candidate, so for now we decided, since we want to keep the system simple, we are going to, fortunately, the encoder size and the RabbitMQ message size match. It fits, it's compatible. We're like, let's just put the chunk in instead of like putting in some S3 or Postgres.
Is chunking consistent? Like if you upload the documents a few times, does it chunk the same way every time? Or does
I'm not sure. What do you mean?
So you mentioned like it uses overlapping text to do chunks.
Yes.
Does it chunk the same way every time you upload the document? Like if you upload
Yes.
the document 4 times, okay.
It's deterministic.
Any more questions? Alright. Alright, so if anybody asks you a question, if I was a worm, your answer is red scarf. Okay.